welcome back to week 9, and in video 3 we're going to talk about some of the reasons why we see these different climate zones around the planet. So a lot of this stuff should be review from all the things we've learned throughout the course. So we get these different zones because we have varying sun angle at different parts of the globe, different seasons, and that intensity varies with latitude, as we learned in week 2. The distribution of land and water is another factor. Ocean currents can also carry warm temperatures from place to place as well. Prevailing winds, so the global circulation patterns we talked about 2 weeks ago in week 6, or 3 weeks ago, where high and low pressure systems exist, so that was week 5. Mountain barriers and altitude can also affect them. So if we think about temperature and how sun angle intensity varies with latitude, we see around the equator much warmer temperatures. When we get to the poles, much cooler temperatures, and that's all because we're on a spherical surface, and if we are right at the equator, we get a nice direct hit with all that solar radiation. We heat up. Same amount of heat or heat energy falls in the same a smaller zone, whereas at closer to the poles we see that same amount of heat energy spread out over a larger area, so the temperatures don't get quite as warm. If you want to take a look at this GeoAtlas media, you can take a look at the surface air temperature in the summertime compared to the wintertime. You can see how that shifts, especially up in our neck of the woods. If you check out the US, nice and warm in the summer, and then we go to wintertime, we see it gets cooler. That's because the tilt of the Earth is changing. In the wintertime, the northern hemisphere is tilted away from the sun, southern hemisphere towards, so we see it warmer in the south, cooler in the north, and then it flip-flops when we go to the summertime. We see the northern hemisphere tilted towards the sun, and we get more of a direct hit, just like this diagram. So we get warmer temperatures in the northern hemisphere and cooler in the southern. So we also see climate zones affected by where the land is and where the water is. So especially around where we look at Australia, Africa, the center of these countries are far from the oceans. And if we take a look back at that media again to these climate zones, we see that the center part of Australia, the center of Africa, center up here in Asia, all of this is far from the ocean, so we get drier conditions. So that can be another factor to influence climate as well. Ocean currents can help to bring warm water and therefore warm air across oceans. So the Gulf Stream brings warm water and warm air across over to Europe, so they get more favorable winters. If you look at their latitude, they're pretty close in latitude in a lot of these places to Canada and Maine, which can have very, very, very bitter cold winters, which isn't necessarily the case all the time for Europe. We also have our circulation patterns and prevailing wind directions. So you should remember the 3-cell system that we have here, the polar, the Hadley, and the Ferrel cell, causing certain conditions around the equator, the precipitation that we see there, the dry areas where the Ferrel and Hadley cells meet, and then again another wet zone where we have lots of precip where the polar and Ferrel cells meet. So it's where those mid-latitude cyclones develop that make it across and hit Oregon and Washington in the winter time. And then here you can see, if we take a slice, if we take this top slice here with the 1, 2, and 3 corresponding here, 1, 2, and 3, polar, Ferrel, Hadley, and we see the circulation patterns where the air is sinking, where the air is rising, where we see clouds, where we see clear skies, and where these different jets are located. When we look at the conditions along those areas around the world, we see a band of dry areas where the air is sinking, again where the air is sinking, dry seasons, wet season where the air is rising, cooling, condensing, another wet season, and then kind of an in-between zone where we have maybe one of the seasons being wet versus the other, right next door to each of those Ferrel and Hadley cells. So we have that precipitation that can be overlapped into those different zones. So locations of those highs and lows can affect them as well. Again, those low pressure systems are where we had the mid-latitude cyclones, precipitation moving across the planet, and those shift in the seasons. If you guys remember back to week 6, so we can look at we have our climate zones, we have our air pressure, we can look at surface summer air pressure, and we can see where the lows are located in the summer. And then if we flip to the winter time, we can see we have much stronger lows that can exist as well. So where those are can also affect those climate zones as well. And then of course we have mountain barriers. So wherever we have a big mountain range, we have that orographic effect that can trap moisture on one side, and the remaining air that makes it over those mountains can cause a lot of evaporation. And then altitude. So the higher you are, you get into that highland climate zone. So definitely check out some of the websites that are linked. You can check out this media as well. You can look at the climate zones and check out the different parts of the world here. So those are our climate zones, what causes them, bit of a review, and what climate is. So I will see you in lab.